Let's look at doing Riemann sums, but this time from a table versus from an equation. So the table gives the value for the rates in gallon per minute in which water is draining from a tank. So we have our top time, which is in minutes, and then our rate, which is gallons per minute. The first thing we want to do is show why the area under the curve determines the total gallons drained after 8 minutes. Okay, so when we're finding the area under the curve with Riemann sum, we're adding up the area of those figures, so either the rectangles or the trapezoids. And to do that, the width, that was always the distance between our x values, and the height was always the y value. So to find the area, length times width, that's just multiplying the space between the x's times the y's. So the reason it's going to give us the total gallons drained is that we're going to take our x value, which is in minutes, times our y value, which is in gallons per minute. The minutes are going to cancel. So minutes divided by minutes will just cancel and just leave us with gallons. So that's why when we find the area, our answer shows us how many gallons have been drained. Now for part B, using a left hand, right hand, trapezoid, and midpoint Riemann sum, estimate the total amount of water drained from the tank during the time from period t equals 0 minutes to t equals 8 minutes. So that's just this whole table. So the first thing you want to do when you have a table is you want to look at your x values, which are the ones on top. You want to look at how they're spaced, and these are all evenly spaced. Okay? And that's always going to give us the width of our rectangles. So the width of all of these is 2. So when they're evenly spaced, I can just take the width and put it on the outside and then add up the y values. So for a left-hand sum, I'm going to add up, starting on the left, all of the numbers, but leave out the one on the right. So that'll be 2 plus 5 plus 9 plus 4. And that is going to give me a total area of 40. And our units are going to be gallons. For the right-hand sum, I can do the same thing, okay, but this time I'm going to start on the right. So I would have 2 plus 4 plus 9 plus 5. Add all these up, multiply it by 2. It is again going to give me 40 gallons. Then for the trapezoid, once you found the left and the right, just add them together. And if they didn't ask me for the left and the right, I would find them, add them together, divide by 2 to get the trapezoidal approximation. Now the midpoint one, this is the one that's different. This is where we have to create a new table. So when it was an equation, I looked at my x values and I took the midpoint of 0 and 2. So I would take 1 and plug it into the equation. Well, when they give us a table, there's not an equation to plug into. Okay? So what we have to do is find the midpoint using these numbers. So what you're going to do, let me erase this. If I look at the interval from 0 to 4, well, the midpoint of 0 and 4 is 2. Then from 4 to 8, the midpoint there is 6. Okay? So what we do is we start with the second column in the table, and then every other column from there is going to be the midpoint of the two numbers that it's between. So just like I did with an equation, I'm going to make a new table for the midpoint, but this time I'm just going to use 2 and 5 and 6 and 4, okay, because 2 is the midpoint here, 6 is the midpoint here, and we don't ever want our rectangles to overlap, so we wouldn't use 2 and 4 and then 4 for 6 and 2, because then we would be creating overlapping rectangles and our area would be too big. So for your midpoint sum, okay, If I look at the space here, it's no longer 2. The space between these, from 2 to 6, that space there is 4. And then I'm just going to add up my y values. Remember, for the midpoint, we use everything here. Okay, where the left and right, you leave one side out. For the midpoint one, you use every value you have for the y value. And so that is going to give us a midpoint sum of 36 gallons. Always make sure you label your answers. If we look at this third problem, the table gives the values for the rates in gallons per minute in which water is draining from a tank. So on this table, it's not like that first one I did, okay? These x values, which is the time, are not equally spaced. So I can't just put a number in front and add up all of the x values. So what you have to do when the tables aren't equally spaced, if we look at this first example, use a right-hand Riemann sum with 4 subintervals to evaluate the total amount of water drained from the tank in the time period 0 minutes to 13 minutes. Okay, so for the right-hand sum, okay, what I'm going to do is start on the right, and the first thing I need to do is look at the spacing of my x's. Okay, so from 7 to 13, that's a space of 6. From 5 to 7, that's a space of 2. From 1 to 5, that's a difference of 4. And from 0 to 1 is a difference of 1. Okay, so I'm going to take these numbers. These are going to be like my widths. Okay, and I'm going to multiply them by their respective y values. So I'm starting on the right. So I'm going to do 6 times 2. Plus, for this one, I'll do 2 times 4. So since we're doing a right-hand sum, I'm always picking the one on the right. So like 4 is the distance from 1 to 5. And so 9 is the y value on the right of these two. So I'm multiplying the 4 by the 9. So this will be 4 times 9 plus my last one. The width is 1. The height we're going to use is 5. So multiply those together and add them up, and you're going to get a total of 61 gallons. And again, the unit for your answer, if you look at the rate, it's always going to be whatever the part is that isn't the time, so gallons. Now for part B, we want a trapezoidal Riemann sum with 4 subintervals to estimate the total amount of water drained from the tank from 0 minutes to 13 minutes. Okay. And it's 4 subintervals because if I have 5 numbers, that's going to let me create like 4 sections. So for a trapezoidal sum, we need the left-hand Riemann sum. Okay, so I haven't found that yet. I've got the right-hand Riemann sum from above. So from the left hand, I'm going to start here and I'm going to do 1 times the value on the left. So 1 times 2, plus this will be 4 times 5. Then the next set is going to be 2 times 9. And then 6 times 4. Okay, so again, with the left-hand sum, I'm leaving this value out. When I did the right-hand sum, I left this value on the left out. So then when I multiply these and then add them all together, that is going to give me a sum of 64 gallons. So now that I have the left-hand sum, I can find the trapezoidal sum by adding the left and the right together and dividing it by 2. That'll give me a total of 62.5 gallons.